This is a brief introduction to what's called summation notation. It is also referred to as sigma notation because it uses the Greek symbol sigma. Okay, now the parts of this, you will see a sequence that comes behind the sigma symbol. K is what's called an index number. So in this example here, it says K equals 1 under the sigma symbol, so that means my first term I would be substituting a 1 into the sequence. And then I finish with whichever number is on the top of the sigma symbol. So we're actually going to look at a specific example of one. Looking at this sequence, I have 2k minus 1. It says that my index needs to start with the number 1. So I'm going to have a sub 1 plus a sub 2 plus a sub 3. I finish once I get up to a sub 6. And to find each of those terms, it's what we had done in the past with the sequence. We just substitute those numbers into each one. And then the last thing, because this is called summation notation, we actually have to find a sum. So it's very similar to a series. In this one, my sum should equal the number 36. And if we look at it, because it's arithmetic, I can group these into 3 groups of 12. So it does equal 36. What I would like you to do is to try out these two examples to see if you can find the sum of each one. So press pause and then start it up again when you're ready to look at the answers. Okay, here's my solutions to each one of those. Something I want to mention in the second example, if you did not notice, this one did not start with an index of 1, it started with 0. So I really don't have 4 terms that I'm adding together. There's really 5 terms because I start out, my first term is really the a sub 0 all the way through until I get up to a sub 4. So that one did have an extra term to add into it. The next thing we're going to look at is writing out each sum. If I start with my first one, my first term would be a 6 because I'm going to substitute in a 1. Then when I substitute in a 2, there's my next term. It's really not practical to list all of these out because it goes up to the 20th one. So we are permitted to use some dots in here. However, be careful with the last number that you write. You don't want to finish this with the number 20. You need to keep in mind that you would be substituting 20 in place of the k, which means my last term I would be writing would be the number 25. Now in the second example, I'm going to start out the same way. I'm going to substitute a 1 in, so I'm going to get 2 over 2, which simplifies to equal 1. When I substitute a 2 in, I get a 3 in my numerator. My next term would be 4 over 2, which simplifies as 2. In this one, there isn't a final term. This one's going on forever and ever. So we are permitted to go ahead and put those dots in there. You could also finish it by placing this as your last term. Now the last thing we're going to do is work backwards and try to come up with the sigma notation. So I'm going to start off with my sigma. I'm just going to use k equals 1 as my starting index. It's a little bit easier. If I take a look at this example, 5 would be my ending number because it starts with a sub 1. That would finish up with a sub 5. The next thing I got to do is try to come up with a formula. This one happens to be an arithmetic sequence because 4 is being added each time. So keeping that in mind, I'm going to go back to this format for an arithmetic sequence. That'd be my first term plus the difference times m minus 1. I'm just going to simplify that using the distributive property. And then I can finish my sigma notation by bringing this over. Now, I don't want to use the letter n any longer because k is what our index is, so I do need to change that n to a k. Okay, final example. I'm going to start off with my sigma, once again starting with 1. This time as I go through, I have a sub 1, a sub 2, a sub 3, a sub 4, a sub 5, a sub 6, a sub 7. So 7 is going to be my number that goes above the sigma. This one is an arithmetic or geometric, so we need to come up with some type of pattern. I think it might be easier to come up with that pattern looking at it if I make the first number into a fraction. By doing that, now I'm just going to view the numerator and denominator separately. The denominator is the same as each term. So that means I would just have a k for my denominator. The numerator happens to be one more. So there would be my pattern for the last example.